In this lesson, you will learn to simplify expressions involving both zero and negative exponents. Now the question is, what does a zero exponent mean? And what does that equal? So zero exponents, one way of thinking of this concept is using some information we already know. So we know 2 to the third power is the same thing as saying 2 times 2 times 2. But maybe another way of thinking of this would be putting a 1 in the front here. If we said 1 times 2 times 2, that's still the same thing, right? Multiplying by 1 does not change anything. So let's actually do this for explaining this concept of zero exponents. So instead of 2 to the third equals just 2 times 2 times 2, we'll put a 1 in the front. Well, now the same thing with 2 squared. 2 squared, you can think of that as 1 times 2 times 2. Okay? 2 to the first power would be 1 times 2. So notice the pattern. Here we have 3 2's, so I have 3 2's over here. The exponent is 2, so we're going to have 2 2's. Exponent here is 1, so we have 1 2. So if we keep this pattern going, 2 to the third power, second power, first power, the next number in this sequence would be 2 to the 0 power. So 2 to the 0 power would be 1 times, and there'd be no 2's, or just 1. So that is the concept, where actually anything to the 0 power will always equal 1. And that is the point I'm trying to derive, is that anything to the 0 power is 1. And here's kind of a way of thinking through why that would be the case. And so it could be anything to the 0 power. It could be 5 million to the 0 power. It could be some crazy fraction to the 0 power. It will always equal 1. Now let's discuss negative exponents. And actually with negative exponents, with this next explanation, we'll see another way of thinking through even the zero exponent. So with negative exponents, there's 2 ways that I can explain this. The first way is using this pattern. If we have 10 to the third power, we know it's going to be 1,000, right? 10 times 10 times 10. 10 squared would be 10 times 10, or 100. 10 to the first power would be just 10. 1,000 divided by 10 gives you 100. 100 divided by 10 gives you 10. So keeping the pattern going, 10 divided by 10 would be 1. And that takes me to the zero exponent. So notice the sequence, 3, 2, 1, 0. I divide by 10 every time, which leads me here to 1 divided by 10. And that's going to be 10 to the negative first power. And I can think of this even as 1 over 10 to the positive first power. And then 10 to the negative second power, keeping the pattern going, I divide by 10 again to get 1 over 100. 10 to the negative third power, I divide by 10 again to get 1 over 1,000. Notice over here this far right column as well, because we want to get to the point where I can just see a negative exponent and know how to convert into this right column. So we see here 10 to the negative first would be the same thing as 1 over 10 to the positive first. 10 to the negative second would be 1 over 10 to the positive second. 10 to the negative third is 1 over 10 to the positive third. So notice the negative exponent, what it does is it creates a fraction where it's 1 over, and then just change the negative exponent into a positive exponent. So that is one way of thinking through negative exponents. Now another way that I can explain negative exponents is by using that quotient property that we discussed in the previous lesson, where we learned that if we divided 2 values together where the base is the same, I can then add or subtract the exponents. So 4 minus 2 would give me x to the second power. Okay, so now, and we discussed this briefly in the previous lesson, but if you had x squared over x to the fourth, so I switch the numerator and denominator, well, I still can subtract the exponents, where I have 2 minus 4, which gives me a negative 2. And remember, in the last lesson, we did not use negative exponents, but we simply subtracted the 4 and the 2 to get x squared, and then we put that value wherever the bigger exponent was. So the 4 is bigger than the 2 in the numerator, so when I divide, I will put the solution in the denominator as well. So we would say that's equal to 1 over x squared. So notice exactly the same conclusion as the previous explanation, where the negative exponent means we have 1 over and then whatever we had, and then change the exponent to be a positive exponent. So this lesson is primarily just pattern recognition, knowing what to do with the negative exponents. So here is an example, and we're just going to go through a bunch of examples. And this first example, we have 6 to the negative second power. So the goal is to write this now without negative exponents. So remember, negative exponents means 1 over something. Here it's going to be 1 over, and then it's going to be 6 to the positive second power, which would equal 1 over 36. Here we have 2 to the negative fourth power. Negative exponent means 1 over, and it's going to be 1 over 2 to the positive fourth power. And 2 to the fourth power would be 2 times 2 times 2 times 2, which would give you 1 over 16. Here's another example. 4 to the negative third power. This would be 1 over 4 to the positive third power. And 4 to the third power would be 64. Here's one more. You have 1 over 5 to the positive first power, which would just be 1 over 5. So now the question is going to be, what if you have something like this, where the negative exponent is in the denominator? Well, I'm going to show you the long way to think of this, and our goal is to just get to a shortcut method of solving. But our goal is to get rid of the negative in the bottom. So what I can do is I know that 6 to the negative second power, so just the denominator part, that right there means 1 over 6 to the positive second power. So what I have is 1 divided by 1 over 6 squared. But then when you divide by a fraction, you are multiplying by the reciprocal. So when you divide by 1 over 6 squared, what you are doing is you're multiplying by 6 squared. Let's pick up on a shortcut that we can use instead of going through this process every time. So take a look right here at this step, 6 squared. Notice if you compare that with the original statement, 1 over 6 to the negative second power, all we did was to get rid of the negative exponent. To make it into a positive exponent, we moved it from the denominator up to the numerator and changed it into a positive. So instead of 1 over 6 to the negative second power, I move it up, make the exponent positive, so now we have 6 to the positive second power. And that's going to be where we're at right here. So that is the shortcut. You can, to get rid of the negative exponent, I can make it positive by moving it either. So let's try that shortcut with this next example. 1 over 2 to the negative fourth power. Well, to make this into a positive exponent, I need to bring this up into the numerator. So I bring it up and I make it into a positive fourth power, which would simply be 16. Let's try this next one. 1 over 4 to the negative third. To make it into a positive exponent, I can move it to the numerator, and this becomes 4 to the positive third power, which would be 64. Here's another one. 1 over 5 to the negative, with both negative and 0 exponents. Here we have 0 and negative exponents, where this entire thing in parentheses is raised to the 0 power. When you see something raised to the 0 power, it's always going to equal 1. It doesn't matter what it is, it's going to always equal 1. So I can replace all of that mess with a 1. And then we want to get rid of the negative exponent. So to get rid of the negative exponent, I need to write this as a fraction. So this becomes 1 over 5 to the positive first power, or just 1/5 as my solution. Okay, now we're going to, in this example, have multiple negative exponents. And our objective is to write this without any negative exponents. So what I would like to do, even though, yes, we have the same base of p here and here, before I try to combine those into one, let's get rid of the negative exponents, just to make it easier to work with. So up here, this p to the negative first power, to make that into a positive first power, I need to move that down to the denominator. So that will become p to the positive first power. Okay, this q to the negative second power, to make this into a positive exponent, I would also bring this down to the denominator, and this becomes a q to the positive second power. And then the p to the negative third power, to make this into a positive exponent, I need to move this one up into the numerator, where now I have p to the third power. So from here, I can then simplify quickly the p cubed and the p to the first power. These can simplify by subtracting the exponents. So 3 minus 1 gives me a 2. So what I have is p squared over q squared. And that is my solution. Here's another one with multiple negative exponents. So to make this q to the negative second power into a positive exponent, I need to bring this down into the denominator. So this p is already a positive. We'll keep that in the numerator. We'll bring down the q squared. And then the p to the negative third power, to make that into a positive exponent, I bring that to the numerator. So that becomes p to the positive third power. So now what I have is p times p cubed. When I multiply, I add the exponents. So I add the 1 and the 3 to get p to the fourth power, and then q squared stays in the bottom. Let's try another one. Here, to get these negative exponents to be positive, I need to move this to the denominator. So now I have p to the first power down there. This q to the negative second power I bring down as well to make it to a positive exponent. And this p to the third is already positive, so I don't need to move that anywhere. And then in the numerator, we're left with just a 1. Everything else is gone. We have a 1 left over. So now I can combine the p to the first and p to the third. I can add the exponents because I'm multiplying. So now I have p to the fourth power on the bottom. So my solution would be 1 over p to the fourth times q squared. Let's do one last example. Here we have 6xy to the negative first power over negative 2x to the negative second power, y to the negative first power. Now let's begin by getting rid of the negative exponents. So here, y to the negative first power, to make that into a positive, I bring that down. So the numerator, we have 6 and an x. Those are, to make that positive, I move that to the numerator. And then x to the negative second power, to make that into a positive exponent, I bring that to the numerator as well. So now I have x squared up here. Okay, and this negative out here is not that's not an exponent, it's just a negative 2. So just leave the negative 2 down there, and so what we have is going to be 6x times x squared times y over negative 2y. Now from here we can simplify. Y to the first divided by y to the first would cancel. And then x times x squared would give me x to the third power. And then the 6 over negative 2 would divide and leave me with a negative 3. So I have negative 3 x to the third. Nothing is left in the denominator. So my solution would just be negative 3 x to the third. And by the way, up here I could have canceled right away. Y to the negative first divided by y to the negative first. You're dividing by the same thing, so those would cancel up there on that step if you wanted. But either way, we get the same solution, negative 3x to the third power. And that concludes our lesson for today. We will see you next time.